An international team of astronomers has completed the deepest spectroscopic survey of the early universe ever undertaken, collecting data on 1,600 galaxies, and discovering 72 previously unknown candidate galaxies. The scientists observed a tiny patch of sky that had before served as the subject for the now-famous 2004 Hubble Ultra Deep Field Images (HUDF). The new HUDF observations were made using the European Southern Observatory's ESO multi-unit spectroscopic Explorer Muse instrument, which is mounted aboard one of four 8.2 meters 27 feet telescopes that make up the Very Large Telescope (VLT), located at the Paranal Observatory in Chile. Muse is capable of observing the entirety of an object at once, and measuring the intensity of light from each point of an image to create a 3D dataset in which each pixel has a full spectrum of light. This allows astronomers to measure certain characteristics of an object, such as its distance and chemical makeup. Scientists analyzing the Muse data have already made some fascinating discoveries, including the presence of luminous hydrogen halos surrounding some of the galaxies that populated the early universe. The presence of these vast structures could help astronomers to understand how star-forming material was introduced to and expelled from these ancient galaxies. The 72 newly discovered candidate galaxies shine in a single color known as Lyman alpha light, which sits on the ultraviolet part of the electromagnetic spectrum. These galaxies, known as Lyman alpha emitters, had previously eluded detection by Hubble and the 8 other telescopes that have carried out in-depth studies of the HUDF from X-ray through to radio wavelengths. As the ultraviolet Lyman alpha light travels through the vast expanse of space to reach our planet, its redshift stretches out into longer wavelengths, causing it to be detected by planetary and orbital observatories as lower-frequency visible or near-infrared light. The existence of these single-color galaxies, which were invisible to Hubble, yet detectable by Muse thanks to its ability to break light down from every point of an image into its component colors, cannot be fully explained by current star formation models. What's more, some of the 1,600 galaxies observed as part of the new survey are incredibly ancient. The light that astronomers are detecting today was emitted by these galaxies around 13 billion years ago, relatively soon after the birth of the universe. By analyzing the newly captured Muse data, astronomers can further our understanding of the processes that shaped our universe in the wake of the Big Bang. Muse has the unique ability to extract information about some of the earliest galaxies in the universe, even in a part of the sky that is already very well studied, comments Jarl Brinkman, lead author of one of the papers describing results from this survey, from the University of Leiden in the Netherlands and the Institute of Astrophysics and Space Sciences at CAUP in Portugal. We learn things about these galaxies that is only possible with spectroscopy, such as chemical content and internal motions, not galaxy by galaxy but all at once for all the galaxies. The new Muse dataset has already given rise to 10 scientific papers, which have been published in a special issue of the scientific journal Astronomy and Astrophysics. The observations are likely to provide significant insights into a wide range of cosmological questions, including how stars formed and moved around in the early universe, and the characteristics of ancient galaxy mergers. View Gallery 3 images.